Have you ever wondered how alternating current, like the power coming from your wall socket, gets transformed into the smooth, steady direct current that powers most of our electronic devices? It is a fundamental process in electronics, and rectifier diodes are the unsung heroes of this conversion. The main specifications for rectifier diodes are crucial parameters that define their safe and effective operation in a circuit. These include the peak inverse voltage, often abbreviated as PIV, the forward voltage drop, represented as VF, and the average rectified current, also known as IO or IF parentheses of V. Understanding why these specifications matter is key to selecting the right diode. The peak inverse voltage, or PIV, is the maximum reverse bias voltage a diode can withstand without breaking down and conducting in the reverse direction. If the reverse voltage across the diode exceeds its PIV rating, it can be permanently damaged, leading to circuit failure. For instance, in a half-wave rectifier, the PIV needs to be at least the peak alternating current input voltage, while in a full-wave bridge rectifier, it is typically twice the peak alternating current voltage. Next, the forward voltage drop, or VF, represents the voltage lost across the diode when it is conducting in the forward direction. For silicon diodes, this is commonly around 0.7 volts. This voltage drop directly affects the power dissipated by the diode, calculated as VF multiplied by the current flowing through it. High VF means more power loss and potentially more heat generated, which can impact the overall efficiency of your power supply and requiring larger heat sinks. Finally, the average rectified current, or IO, specifies the maximum average current the diode can safely pass when it is forward biased. Exceeding this rating causes excessive heat buildup within the diode, leading to thermal runaway and, ultimately, destruction of the component. Therefore, carefully matching the diode's IO rating to the expected average load current with a healthy safety margin is absolutely critical for long-term reliability. When you are designing a rectifier circuit, you will need to consider these specifications carefully. First, ensure the chosen diode's PIV rating is significantly higher than the maximum reverse voltage it will experience in your circuit. Second, factor in the VF when calculating the efficiency of your power supply and estimating the power dissipated as heat. You might choose a lower VF diode, like a Schottky diode, for very high efficiency applications, although they typically have lower PIV ratings. Third, always select a diode with an IO rating that comfortably exceeds the average current demand of your load, preferably by at least 50%. Beyond these primary specifications, more advanced designs might also consider the diode's reverse recovery time. Often written as TRR, this specification is vital in high-frequency switching applications, where a slow recovery time can introduce switching losses and distort waveforms. Another important rating is the forward surge current, or IFSM, which indicates the maximum non-repetitive current the diode can handle for a very short duration, critical for withstanding inrush currents at power up without damage. By thoroughly understanding and appropriately applying these key rectifier diode specifications, you can ensure that your power conversion circuits are not only efficient and reliable but also robust enough to handle the demands of their intended application. Proper selection based on PIV, VF, and IO will prevent costly failures, optimize performance, and extend the lifespan of your electronic devices.